Online? Yeah? Okay, hey. Yeah, hi everyone. Thank you very much for joining us for our second live streaming event for this year, 2020. We hope you enjoy the tour through our PET line today we have installed in our laboratory. Thank you very much at this point in time to our nice partners from NGR who supported us with their liquid stage reactor that's embedded into the line. Today we show you a concept that brings you some steps further, not just one, some steps further into a circular economy as we turn waste, literally waste, post-consumer recycling with high moisture and high contamination into a crystal clear sheet that is food grade approved and certified, so you can easily thermoform it back into a food tray or into any other food packaging application. Just for you as an information, my colleagues Gerhard and also Mr. Heenberger from NGR, they are there for you. You can chat with them and they will reply to whatever question you have, just to not interrupt us showing this line. So yeah, take the advantage of our chat function. If you have questions, they will reply to the whole group, yeah, that everyone gets answers and that we don't receive the same question multiple times. If you have a mobile device such as an iPad or a cell phone, you're going to find a question mark in here. Just type in your question and you get an answer. It will pop up on your screen. If you have a desktop computer or a laptop, you're going to find a chat function on the right bottom side of the webinar software menu. So yeah, we hope you enjoy the tour. Get yourself a mug of coffee, make it feel comfortable, and we'll see you in a couple of minutes. Bye. Okay. So welcome, ladies and gentlemen, to our second live streaming event for this year, for 2020. We will be showing you a PET sheet extrusion line today. Today we are converting post-consumer recycling raw materials, so-called bottle flakes. And yeah, we hope you enjoy this event today with us. We will be showing you some different opportunities we could provide, and we'll explain in detail what this line is able to do and how a liquid stage polycondensation unit from NGR is embedded into our line and how everything works together. Now, as you can see on the back side, in this particular case, we have a conical twin screw extruder coming with our line. We decided to have a conical twin screw extruder to have a better degassing compared to a single screw extruder, which could also be embedded into the line. But as you may know, PET extrusion, this is kind of an individual thing. So some people use single screw extruders with pre-drying systems. Some use twin screw extruders. We decided to use a twin screw extruder too, and used a conical twin screw extruder to get rid of an additional melt farm to create enough pressure to run through the first screen changer prior to the LSP reactor. Now, the next graphic I'm going to show you is outlining the line capacity or the line specification. So this line is designed with the road stack for a PET sheet that has a 1 meter width. We can run from 200 microns up to 1,200 microns in total. If we want to go thicker or thinner, we need to add additional systems like air knives or vacuum boxes and stuff like that to go thinner, and other road stacks to go thicker. In that particular case, we would have to add a horizontal road stack to get better control of the melt flow and the melt behavior within the first nip. That creates the final sheet quality and sheet thickness. Now, in this particular case, we still have an inclined road stack, as this is our lab line. It has been reworked and redesigned a couple of times over the last years, and it's going to be exchanged into a newer line concept within the next couple of months. But let's go through the line. We have a monolayer sheet today coming straight out of the die, out of a LSP reactor, but we have also a co-extruder to run ABA sheet or AB sheets. We can, of course, add additional extruders if required. And the line has a maximum speed of 65 meters per minute in total, which equates to roughly 180 feet per minute. Now, if we have a look at different line concepts we could provide, which is shown on the next graphic, we will again explain a bit more in detail what we could offer. We have different line concepts, as mentioned before, with twin screw extruders as being shown here, usually without pre-drying. So that's the advantage we take out of a twin screw extruder. There's no pre-drying system installed currently. We run with the PCR material as it comes in octabins straight into the line. We literally ruin or destroy all the molecular chains within the melt and supply the melt straight into the LSP reactor in order to upcycle the material and to repair all the chains. We can also do the same with a single screw extruder, but it always depends on the raw material on the incoming side and also the throughput you would like to reach. Another alternative, if we use single screw extruders instead of twin screw extruders, are crystallization units or drying systems such as IRD dryers that could also bring raw material to a FDA approved grade specification. So that's also an alternative in order to create or to get a line that's capable of running post-consumer recyclings in the future that could still be converted into food packaging applications or even trays. Rather than this, from time to time, we supply single screw extruders with regular pre-drying systems, conventional pre-drying systems, or IRD dryers that don't provide food grade approved melts. That would be for non-food applications, could be trays for different industries and stuff like that. Now, if we have a look at the next graphic shows the line from the top. So that's the top view of the line. And as you can see, the line is still very compact. Even including that LSP reactor, we just require a bit more width, and but not so much more length, and take advantage out of both worlds. The system from NGR is much more compact than any kind of systems we could add prior to the extrusion. So these dryers are usually much bigger and not that compact, and they don't work that fast. Now, if we go further downstream the line, the next important item is a screen changer. If you can come a bit closer, Theo. So the screen changer we have embedded into the line is a double piston screen changer. A double piston screen changer is usually good enough for regrinds, but we figured out, especially during the last days, when we added raw materials with higher contamination and higher moisture, that a quadruple screen changer and even one with a backflush option or a rotary screen changer might add benefits to the overall system in terms of screen changing times and line stability. Now, next to the screen changer, the next important item is a melt pump. So that melt pump controls the flow pressure and the flow speed to a very accurate and precise level in order to feed the LSP reactor, which is on my left side, properly and always very constant with the same kind of filling level. And next to it, we added a bypass valve, which is very nice to start up the line, to clean everything between the reactor and the extruder so that we don't push contaminated material that was maybe sticking on the flow channel walls over a couple of hours into that LSP reactor. Now that would require a longer changing process or a longer cleaning process we want to avoid. That's why we have a bypass valve. So we start the line, we open the valve, we let the material run out for a couple of minutes, we close it, and then we process straight into that reactor. Now, for all of you who don't know how such a reactor works, we have some graphics and also some videos. Now, the following graphic just shows that the LSP reactor, for example, has a very high cleaning efficiency. So on the one side, we have a vacuum system, a huge vacuum system that has the biggest impact on the LSP reactor. Added to it, the LSP reactor is more or less a returning drum. We return the drum with a very low speed. It's just 1 to 2 RPMs per minute in order to create a big material surface that can cool down in order to create a skin, which then again is mixed back into the hot melt on the bottom of that reactor and then pulled upwards again to increase the surface again for moisture and moisture and also contamination takeout via that vacuum pump. And as you can see, depending on the molecular weight of the contamination inside of the melt, we have a very high cleaning efficiency between 98 and 100% of chloroform, for example, and other chemistries that could still be mixed into the melt. If we have a look at the next graphic outlines that also the time the melt remains inside of the LSP reactor is very fast compared to other systems. Now, certain drying systems prior to the extrusion process, they require hours of drying, especially solid state reactors, as you don't get access to the moisture and the contamination that's embedded into the flake or into the granulate. Now, as we have a liquid stage process here, we get much better access to the material, and the time the melt remains inside of that reactor is usually fixed. So we keep the material inside between 30 and 40 minutes. That's more or less the best time for the material to stay in, to not increase the IV too much. And also the temperature is kept on the same level, and we just increase or decrease the vacuum power to get more moisture out or less moisture out in order to keep the IV value on the same level all over the time to improve your product quality and the thermoformability at the end of the day. If we have a look at the next graphic, we're going to see a graph that clearly outlines the incoming raw material, which comes in more or less with destroyed molecular chains, and they have an IV of 0.6 or 0.64, very low, not thermoformable, and we increase that internal viscosity and we keep that level. There's a viscosimeter on the backside of that LSP reactor. We measure the IV from the material that is supplied, straight into the die tool, and we control the vacuum up and down in order to keep that level very precise. Now, if we go around that LSP reactor, you're going to see it's very compact from the side. And we have that LSP reactor on load cells. So the load cells give information about the filling level of that reactor. There's no other way currently to have any kind of idea how much material is inside, rather than just weighing it and keep that filling level. The LSP reactor in this particular case is the master, so we're going to tell the extruder you need to supply more or less material to keep exactly that kind of weight. Now, if we walk around the line, we're going to see the same kind of graphic on the NGR screen. I just turn it around so that you can have a look at the screen. So this is again the internal viscosity that is supplied from the reactor into the die tool. As you can see, we keep it on a very precise and equal level. We have now internal viscosity of 0.8%. So we got the material almost destroyed. We lifted the internal viscosity up to 0.81, which is still a very high level for most of the thermoforming applications. But if you're capable of managing such a high internal viscosity, you can take advantage of the stiffer material. So with less raw material consumption, you can increase mechanical properties as the material is more stiff once we created the sheet. If we walk around that panel here and have a look at the inside of the line, we're going to see again a 2-piston screen changer, a bit bigger than the previous one, as we filter here the melted material, so we get again better access to all of the contamination. But also here we would recommend a bigger screen changer, maybe with 4 screens, rotary systems, or any kind of system with backflash function. Now from here we supply the raw material straight into the feed block. So that's the next important item downstream the line. We have a bolt feed block here. A bolt feed block is capable of providing sheet configurations from 2 layers on. So we can use that for ABA sheets or AB sheets, and we can add another bolt feed block to create up to 5-layer sheets. We have also a co-extruder integrated into the line, as you can see on the back side, which is switched on today. And from the feed block, we go straight into the die. Now, in terms of feed blocks, we can provide, again, different kind of systems. The next graphic shows you how that bolt feed block looks like. And a bolt feed block is fed from the back side. The co-extruded melt is supplied. It's coming in from the side, and it's supplied into turnable bolts, as you can see on the side here. Just painting into my board to figure out that everyone knows where the incoming channel is. It's right here. The melt goes into the feed block. It's distributed around the bolt, and the bolt has a conical opening, so we can add the additional layer more narrow or more wider in order to take advantage of different raw materials and melt flow behavior into the edges of the die and into the edges of the sheet. So depending on the raw material and the viscosity, we would turn that bolt to a more narrow or to a more wide position. We have also lamella feed blocks. If you have a look at lamella feed blocks and how they're looking like, I'm going to show you the inside. Now that's how a lamella feed block is designed. A lamella feed block is usually used for sheets that come with more than 5 layers, and for sheets that have a very narrow and very thin embedded layer in the center of the sheet lamination. So this could be used for EVOH and stuff like that. But even if you have different viscosities within your PET grades, you could take advantage of a lamella feed block, as you can profile each layer individually, as you can see on the graphic. I'm going to show you again with my pen what we're talking about. Just 1 second. Now we're talking about that kind of profilization. Now you need to imagine that every material tends to flow to the flow channel sides and to the sheet sides or to the die sides anyways. So if we have a raw material that comes on top on the outside, we might add a bit more of that raw material in the sheet center if that raw material has a very low viscosity. Now, once it comes out of the die tool, once it gets into the calendar or into the roll stack, the layer distribution is very precise and equally distributed. So beside the opportunity to profile each layer individually to create a very proper layer structure once the sheet gets out of the die tool, the lamella feed block has also some other advantages. We have two inserts. We have the lamella insert you see on the screen. That's a plug and play system, a fast changing insert for different raw materials, for different viscosities. You can take one insert out, put another insert in for another recipe, another layer structure, another raw material grade in order to create less shutdown times, to increase the profitability at the end of the day. And we have also a manifold on that lamella feed block, which gets melt from the extruder and distributes that melt into a specific layer position. Now, by changing that manifold insert, you can guide melt from the top to the bottom for the next product or into the centers. You can run regrind out of the center to two sides or to one side only. So these are some additional advantages. Rather than this, the advantage of a lamella feed block in terms of bringing different layers together is that all the layers come together at one particular spot, right on the tip of these heart-shaped lamellas, and not in flow direction. So some of our competitors, they have similar systems. They look similar from outside, but if you have a closer look, you will see that these systems add layers to layers in flow direction. Now that creates turbulences, that creates counter pressures, that creates problems coming with different flow speeds. Now bringing all the layers together at one particular spot with different profiles and very precise adjustable lamellas, very narrow and thin lamellas, that has a huge impact on your product quality. Now that lamella feed block could also get a bolt feed block to its backside in order to add additional layers like high gloss layers, anti-static layers and stuff like that. Now, if we have a look at that road stack, all of our road stacks are all electric, beside road stacks for certain PET applications and for the North American market. So we have also a all electric road stack in here. Main advantages of all electric road stacks are the energy consumption. So we use high quality spindle drives in order to bring all the rolls into a specific position and keep the roll in that position without adding energy. A spindle drive is mechanically fixed. Once we stop the motors, we don't even need a brake on the motor side in order to keep the roll at that position. We create, or we can also fight against high counter forces. There's nothing moving into any direction. We can also have a look again on the road stack. We created at the beginning of last year for PET applications. That's the road stack you see on the slide for the line specifications. Now that road stack, that's hydraulic driven. We have a horizontal road stack instead of an inclined road stack to create a better process controllability if we go on much thicker sheet. Now that sheet here is 1200 microns. If we go thicker, we take advantage of a horizontal road stack, and also for high-speed applications. And that road stack is also then hydraulically driven. Now, if we provide a hydraulically driven road stack, we have servo hydraulics, not black and white hydraulics. So even if it comes to hydraulics, you should have to have a closer look on everything, on every detail. We provide servo hydraulics, so you can adjust both pressure and the way of the cylinders. There are linear measurement systems integrated into every cylinder, into every hydraulic cylinder, in order to control the way and also the pressure. It's not a black and white hydraulic that push with full force all the time. You can adjust the force you want to create for so-called KISS processes or very thin sheet with auto gap control die tools, and Once the melt gets out of the die, it's not pressed into any direction from the roll anymore. The roll reacts against the counter force and is not keeping everything on high pressure in order to ruin the profile you just extruded. Now, prior to the roll stack, of course, could come with several other options, such as swivel rolls on the backside if you require a multi-purpose roll stack. We can provide fast changing systems if you run different embossings. So the bearing housing is subdivided. You get guiding rails that take the roll out on demand, manually or motor driven. So if you run different profiles and if you want to take advantage of doing this, roll stack integrated to not heat up the sheet anymore, that could be a solution for you. Yeah, we also provide air knives and vacuum boxes for high-speed applications for very thin sheets. And yeah, in front of the roll stack, we have our dies. So that's another advantage, or yeah, I would say benefit of cooperating with KUHNE. KUHNE provides everything out of one hand. That refers also to the extruders and to the die tool. So now we have very strong cooperating partners such as NGR if we would like to integrate any kind of special purpose technology into our processes. But rather than that, KUHNE supplies everything from the feeding section all the way down to the winder, also dies and feed blocks. So everything comes from our daughter company, KTool. That's a facility just around the corner, around the block. They have a very new building, very new machinery in order to do all the milling and turning jobs. They have their own engineering department in order to create customized solutions, customized screws. So if you require a new screw design, as your melt quality is not good enough or the throughput is not high enough, just get back to us. They run through some calculations and get back to you, all of you, with a proposal. And we do the same with the dies. So that's a very basic die for PET applications without any kind of deckling. We wanted to show you a die with internal deckling, but that just has been sold. So I'm really sorry that we don't have the opportunity to show that to you today. But yeah, customers first, as most of you will understand. And a die tool with integrated deckling looks like this. So it's a T-channel die. We have an internal deckling added to the die tool on both sides. As you can see on the right and on the left side. 1 second, I will paint it for you, just that everyone can keep on track. Now that's the position where the internal deckling is. This is how the internal deckling looks like. We have a hand wheel on site. Now that hand wheel is installed to the die to shift the blades in and out manually. We can also add motors in order to do so. And that die tool has also a auto gap control. An auto gap control looks like the one on the right side. In that case, we had thermo bolts. Now that thermo bolt adapter is connected to the thickness gauge on the roll stack backside. The thickness gauge gives information back to the thermo bolt in order to open or to close the gap a bit more depending on the profile of your sheet. Now, if we want to go a bit more advanced and a bit more flexible for all these custom sheet manufacturers and a bit more in time and requiring less energy, we can also install Maku die tools from our partners at Maku. Now, these die tools are linear robots that run across the sheet width, and they install every single bolt individually, and they also keep on track of the position of the bolt just in case any bolt gets broken and need to be exchanged. Now, the advantage of that robot is it works in time once it's required. A thermo bolt is a heating element such as a heater band, so it consumes energy all the time, and there's a break-even point somewhere around 1.20 meters to 1.50 meters when it definitely makes sense to think of an initial higher investment for that linear robot compared to a thermo bolt, as the faster startup times, the less energy required. That pays off in the medium term run, for sure. Now, if we go back to the front side and have a look at the controls again, just that everyone could keep on track of what we're doing here today. let's have a look again on the fourth slide I have showed you in the beginning. Now, this is what we're looking at if we talk about PET processes. We have material with less moisture or higher moisture with less contamination and higher contamination. And we have applications that are okay with no food certified raw materials, but we have also some or a lot of customers outside that would like to convert post-consumer recyclables into a food packaging again. Now, therefore, we need to integrate any kind of reactor or any kind of special purpose dryer prior to the extrusion or integrate it into the extrusion. Today, we show you a system from our partners at NGR. It's a one-stage reactor. We can also add a second stage reactor prior to the one we have installed in here. This is a so-called spaghetti pot, and that spaghetti pot pushes melt through a screen in order to increase melt surface again. It's also connected to vacuum. As mentioned before, vacuum has the highest impact on decontamination and demoisturizing of the melt, and that would again lift your IV by some more percentages compared to what we're doing today. But today we lifted the IV from 0.64% already to 0.84%. And yeah, both companies worked hard on the control panel to make it a bit more self-explaining. Now the control panel from NGR is very easy to operate. You see all the basics, you see the throughput, you see the tonnage of melt that's inside of the drum of the rotary reactor. You see also the internal viscosity once it comes out of the die. You see the pressures on the screen changer and the line speed. And also, you can also figure out what the vacuum system is doing. Another advantage of that reactor is the fact that we control the IAV value independent of the recipe. So on the raw material side and on the extruded side, you can immediately or in time add other raw materials or another octabin. That other octabin might have a higher moisture, higher parts per million of moisture embedded into the flakes, but it has no impact on the process. The process remains on a very stable level, and that gives us advantage and a better controllability on the road stack side and on the thermoformer side. Now, if we have a look at the KUHNE control system, so this is what we call a KEC control. The KEC has been invented a couple of years ago. It's a Siemens-based control. We redesigned the control panel in order to make it more self-explaining, as good skilled people become rare all over the place, and that makes it challenging, not just for us as a machine manufacturer and not just for people in first world countries or third world countries. That's a global phenomenon. Everyone is struggling to find people that are good trained, that have good skills. So a machine needs to be more self-explaining in certain ways. We created a couple of nice items. The machine has also some nice features like a linear speed up function. So by turning that hardware button, you can speed up the whole line linear. You don't need to push every button like in the past. It's very nice. We have also a lot of data and analysis already integrated into the line. So you see pressures and throughputs and all that stuff on a graphic. You have one page dedicated for all the extruders. We have another page dedicated for all the temperature zones that need to be controlled. We have another page that's dedicated to the raw material supply to see what's currently going on, what's coming from the feeding section. And we have, of course, a home button that gives you all the key performance indicators of that particular line. Just in time, quickly, a brief overview that you all know what's going on currently. Now let's swivel this one back. The next important item downstream the line is the thickness gauge. As you can see, everything is very straight. We have a very precise profile control right now. So everyone in here is happy. The sheet, as you can see on the back side, that's crystal clear. So just to refresh your mind, we take waste, literally waste, post-consumer recycling, and create a crystal clear sheet out of it. There's no master batch added, nothing. So that's very nice. and the profile is also very accurate, so we are not over consuming our raw materials. Even if that control is not added to an auto gap, we adjusted everything precisely on the die tool to have a proper sheet flow, a proper product quality at the end of the day, and to not over consume raw materials as we go too close to minimum values in terms of our thicknesses. Yeah. Now, what else could we offer to the road stack? We have some other things we could add to the road stack, for example, such as laminating stations. We have a road stack integrated lamination station, such as on the picture. Now here you see a swivel device. Now that device is mounted on the road stack backside. We have a pressurized roll and also temperature controlled roll that could be swiveled around the center roll, also on a horizontal road stack, in order to find the most suitable spot for lamination processes on the second nip. We can also have laminating units for the first nip, so we would go into the road stack from the front side with any kind of barrier film and stuff like that. But to do it on the back side, that's a very common procedure. And the next picture will also show you some advantages of that system itself. Now that system is swivelable, as I mentioned. You can also adjust the pressure in order to find the best peeling force related to your product. You have also the opportunity to add a tension control system with a tension control roll and also a denser. So even if we do the splicing, or even if we start with the next film to be unwinded, we keep a very precise lamination force measured and automatically controlled. For those of you who would like to require the most advanced technology, we have motors installed that create or that control the tension for the laminating processes if required. These motors could also act like an electrical generator, and that electrical generator could feed electricity back into the system in order to reduce the overall energy consumption. For those of you who would like to improve their green footprint and their energy consumption, that's yeah, a very, very precise and nice way to do that. Of course, we have different unwinder options available. Usually we use A-frame unwinders or two-position unwinders, very basic. We can talk about different splicing processes depending on the fact that you can have a huge overlapping. You can also have an unwinder that just brings the old sheet face to face with the new sheet without overlapping, but it always depends on your product, on your process. But that's what I mentioned before. That's like the way we're doing it for most of the PET processes. Now, if we have a look at the next picture, the next picture shows a laminating process downstream the line, so we can also integrate a laminating station downstream the line. That laminating unit would come with a similar to a road stack, a tiny 3-row road stack, as you can see on the picture. I will just mark it for you again so that you can properly follow up. So that's the unit we are talking about. Prior to that unit, we from time to time we have adhesive stations like here. We can also add a hot melt extruder on top of a platform, depending on the peeling effect you would like to achieve or the films you would like to bring together. Now, if we go further downstream the line, in here we have a silicon bath, very simple silicon bath. We can also add any kind of surface treatment with sprayers, much more precise than silicon bath with a roller integrated. Now, depending on the adhesive or on the surface treatment you would like to achieve, a spray unit might be the better solution to not overconsume all the raw materials. We can also add a station for anti-fog materials, and of course corona treatment systems for the bottom and the top. If we go further downstream the line, so as you can see, we have a roller conveyor section here, very basic. Here's the Hall of unit. And then behind, we're gonna have a accumulator depending on the line speed. That accumulator is faster or slower. And behind, in that particular case, we have a A-frame winder, 2 positions. And prior to that A-frame winder, we have a cutting device. Now for PT, we use rotary knives, as you can see from the side. They're adjustable from outside. This could also be motor driven, depending on the pocket money you would like to spend, depending on the level of automatization you would like to achieve. We can also add center cuts if you want to create a multiple web production. And if we talk about winders, we have again different options available. Now that A-frame winder, that's kind of a market standard. We can also add turret winders for higher speeds and for more automatization, or central contact winders if you go on very thin sheet, not too thick. And yeah, I think that gave you a bit in a nutshell about what we're doing here in our lab and about our capabilities together with NGR. Maybe we can have another look at the sheet. Theo, maybe you can follow me. Just to show you that the process is very stable and that we brought the sheet to a very transparent level. It's not brownish in any way. Yeah, so this is coming straight from the reactor, extruded through our line. There's no master batch added, and it's crystal clear. So if you want to turn, if you want to get into circular economy, that's a big topic. If you want to create something good out of waste, that's definitely a solution you should have a look at. So yeah, thank you very much again for your patience and for your time today. We hope you enjoyed the tour through our development center. If you have questions, I hope you were able to clear all the questions with my colleagues along our chat. And if you have questions afterwards, just send us an email or give us a call. Our contact details are shown on the next graphic. And yeah, I would like to thank also my colleague Theo, who's behind the camera. So this is how Theo looks like. 1 second. Now Theo was with me behind the camera, and also Gerhard. We were pulling our TV station, very basic equipment, and we are very happy to have this done without any camera team this time. And yeah, it was a lot of fun for us. If you want to reach us, like I said, the next graphic shows you how to do that, and it also shows you the contact details of NGR. So thank you very much for your time, and we hope you enjoyed the tour. And see you next time. Bye.